Right, so next up is Starship Troopers, and we've got a problem with the shooter. Seems okay, but basically it's near impossible to launch the ball. We'll let the auto plunger do one now. That's okay, but sometimes that's not strong enough as well. So let's take a look at that. Well, there's not much I can do with this one. I hate these metal bushing ones. So what I've done is we'll put a tiny little bit of oil on that. It is actually clean already, so I didn't think it'd be a problem. Now it seems to move a lot easier, so we'll give that a try. The other thing I'm going to do, that's a bit worn out, I'll grab a new one of these. What I might do is just stuff something at the end of there. I could do with a slightly longer shooter rod. Might see if I've got one, but if I haven't, I'm just going to put something in the bottom there just to move the plunger tip out a little bit, because it's not. Let's have a look. We can't really see the auto plunger bracket. Let me just move it forward. So this plunger tip is kind of hiding behind here. It's not really getting through far enough. It needs to be lined up reasonably well with that. So if I just extend it out a bit with something, I'll go and grab a new one, and then hopefully that'll improve things. Right, so I've put a couple of washers in the end of that, and it's still behind it, but it's actually a bit closer, so let's give that a try. Oh, that's perfect. No problem there at all. Let's turn off, it's very noisy, but that seems perfect, and that's ready to play, so we can move on to the next machine now. Right, so Starship Troopers, did a quick play test after fixing the plunger, and it's hard to advance the planet, so I don't think the switches are all working properly, so let's go through these. So we're in switch test, you'll hear the noise when it beeps. That one's bad, needs long travel to get to activate. Good, good, good. Bad, 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 bad. Not great. Okay, bad. So we've got long travel there, dead, 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 and then dead red one. Okay, so I'm going to guess there's a broken wire for that many to be out at the same time, so let's lift the playfield and take a look. Right, so I see one easy fix. This is the right hand red target, that's just off. Don't see anything broken that's obvious yet. Well, this isn't very well tied up. Oh, that mounting post is snapped there, that's why. I've got some more of those somewhere, I'll have to get that replaced. Right, I need to find out what's broken. So it appears there's actually quite a few problems going on with the switches, and this has potentially got an entire column or row out. I don't have the switch matrix diagram, so I'll have to look it up on my phone shortly. So if you look at the ball trough, you can see there's a switch there that's registering as on. If I drop the ball in the trough, you'll see it just briefly flash across, but it's now showing that there's a ball in there. Now if I clear it out, that ball, if I clear it out, you can see that switch no longer active. That's not the case, so that switch is stuck on. And here's the active switch test. So what we're seeing is 4 ball trough, so that one that we just looked at in the trough test, and additionally the left orbit. Left orbit is, let's see if we can see it, it's an opto just under that ramp there. You can just, on the left there, you can just see the hole where the opto is. So that's not working. We'll check the connections on it. I think I've had broken solder joints on a lot of these Sega games on the optos. We'll check that out. If not, it's potentially got a failed opto on it. But that one is stuck on. When a opto is stuck on in the game, especially in the Segas, that usually means that the opto is out rather than actually on. So when the opto is disconnected or completely not working, it'll often show stuck on rather than saying it's not on. Right, so I've done a bit of poking around with the switch test. So column 4, so next to the one that's lit up there, that's the opto that's stuck on in the trough. I haven't seen, so I've pressed every switch on the playfield and I haven't seen anything in that 4th column come on. Additionally, I've noticed that the left ramp enter switch does not work. So I'm going to go and look on the internet for the switch matrix diagram. I'm going to bet that that ramp and all of those stand-ups, so that was one of them, that was one, oh no, that one's okay. So that one and those 4 there, plus that ramp, I'm going to guess that they are all on the same, which will be column 4, which is a drive. Let's go and find that. Right, so there we go. I found the switch matrix on the internet. It's just in the manual. So if we look at column 4, left ramp enter, there you go. So that's one of the ones that I said isn't working. Left ramp exit, I didn't check that one. Left ramp stand up yellow. So I'm guessing that's the one in front of the ramp. Pop stand up blue, pop stand up green. So those are the 2 nearest pop bumpers. VUK stand up green, VUK stand up blue. Those are the 2 that are next to the kick out hole from the Starship Troopers. And right, right ramp stand up yellow. Left ramp stand up yellow and right ramp stand up yellow. So one of the front targets was working, funny enough. So I'm not sure about that. I need to look into that further. But it appears that pretty much everything on that row is not working. I'm just going to recheck. Right stand up yellow and left ramp stand up yellow. Right ramp stand up yellow. Okay, so I thought one of those was working. Let's go check. Right, so knowing what we know from that diagram helps us out a little bit. So if we try and remember, we've got the pop bumpers, blue and green that don't work. We've got the VK blue and green that don't work. We have that one is working. So there you go. So it's not. So that's 1, 2, 3, 4. If we look, it says right ramp stand up yellow. So that's one of the ones that we're like, oh, okay. So if we've got any of them working, we know that the drive on the CPU board is okay, which is good. So we're most likely looking at a broken wire. So we know this one isn't working. We know the enter ramp isn't working. The exit is that one. That one's working. 1, 2. Interestingly, so we've got the second row working and the 8th row working. So I'm not sure where the break is in the wire, but it does definitely look like a break in the wire now after knowing that. Right, I need to basically trace the wire. I think it tells me the wire colour, doesn't it? No, I think I need to go to draw, that'll give me the wire colours. I'll trace out the wiring and I'm sure I'm going to find a break. Right, back onto the playfield. So I'm just looking at the wiring. So the drive is the green, so in this case it's green and yellow. This is the left ramp stand up, which we can press and nothing happens. This one's the end of the line, so we obviously know the break is further up. So we basically just need to trace that until we find a switch that doesn't work. And when we find the switch that does work, then we'll find the next one adjacent that doesn't work. So let's get looking into that, and then just to confirm, so these are the 2 stand-ups for the pops. We've got green and yellow, green and yellow. These 2 are these are the pops. Those are the VUK. So green and yellow, and we will carry on looking. I was having a quick think about how I can test this. So I'll start my meter into frequency mode. So we're showing the number of hertz, showing nothing currently. Let's grab this. So we've got the black leads attached to the ground strap. Red lead we will put onto a known working drive. So we do so. And we see 244 Hz signal, that's the drive pulsing away. Additionally, we'd be able to measure a fluctuating DC voltage as it is pulsing it at 244 Hz. This meter will average it out, so you'll probably see maybe 2 or 3 volts showing up. We'll do it this way for now. So if we go to non-working, now we're seeing 50 Hz. Now all that is that's the interference of the mains wiring effectively, which is 50 Hz. So we're basically just picking up that from the transformer, but nothing at the switch. So if we find this one, which is working, oops, guess what? Well, I'll just show you. So that's the working side, 244. Be just poking that. That's just come off when I just poked that connector. So I'm pretty sure that's going to be the one that's dead. I'm pretty sure I didn't just break that then. I think I just basically knocked it out of there. So we're going to have to pull this off, and we'll put a standard Molex connector on. What's that, 0.1? And we'll put the 2 wires into the pins. Okay, I've got some tools together. So I've got a new 2-pin housing, 0.1 Molex. Got my wire snips, my automatic strippers, got pins, and the all-important Molex crimping tool. So let's get to work. Right, so we have the new pins are crimped on. I've had to modify this housing because it will not fit. So basically I've just snipped away the tabs and left the front ramp on. Where's the broken one? As you can see, these older style crimpy, well, push fit housings are smaller, but we should be able to angle that in, and we're going to have to put some force into it because there's this little tab here, and that is now connected. So let's power up and see if it works. Right, we are powered up. So we've got front ramp, that's the yes. We know the exit ramp works. Green, blue at the VOC, green and blue at the pops. And the front of the ramps, they are both working. So that's all good. The only one that we've got an issue with remaining is this lower green one. Yeah. This one is underperforming. You need to give it quite a shove, so it needs a new switch fitting, which I can do. I'm pretty sure I've got some of those in stock. Right.